So we're taking this. They developed a shorter way to do this. So this method I'm going to show you is called synthetic. We're only doing this for linear divisors. So easy linear. So linear, remember, has a power of 1 on the outside. So if this was x squared, you can't do it, right? So it won't work. It only works for linear. It only works for the simple type, and I'll show you that pattern later on, but let's look. So it's going to be just linear. Okay, so linear divisors only. It's called synthetic division. And what they did is they just said they found kind of a short form to do this. They said, but if it's always a linear divisor, and if I assume that there's a 1 in front, and I'll show you what to do if it's not a 1 in front later on, but we're going to practice just with the 1 in front. So if this has a coefficient of 1 in front of my linear divisor, then you know that when you divide an x squared by an x, my answer will have an x left, because x times x gives me x squared. Then they went, wait, but hold on. So I'm just going to do some hypotheticals over here. If I had x to the 4 plus da-da-da-da, and I was dividing it by a linear divisor here, what's my answer going to be? It'll have x4 divided. I know it'll be x3, da-da-da-da, right? Okay, so if I had x to the 5, da-da-da, and I'm dividing it by a linear question mark divisor, what's my answer going to have? X to the 4, down, 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 down. And they went, okay, do I have to write the x's? Can I just write 1, 7, and 10 and just work with the numbers? Because I know that the variables are going to match every time because I'm doing a polynomial division with a single linear. So it's always going to be, so they said, you know what, let's not write the x's. I'll fill in the x's at the end because I know that it'll be 1 less than whatever I'm dividing by. So I'm going to not write the x's. So they said, okay, yeah, that's a great idea. So I'm going to write it, they write it upside down to show it's synthetic, not long divisions. They write it this way. They make it straight. I don't know why they make it curved, but they tend to write it this way. Okay. Then they said, you know what? So instead of writing x to the 5, 4, 3, 2, 1, I know when it's a linear divisor, I know what it'll be. It'll be 4, 3, 2, 1. So then they just took the coefficients. So they just went 1, -7, -10. Don't copy this. I'll do it again with you on the next page. They said 1, -7, and 10. They just grabbed, -10. They grabbed the coefficients. They said, yeah, because I know if I'm dividing it by x plus 2, it'll be 1 less, right? So why bother writing x4? Especially, this one's easy because it's squared. If I have 4, 3, 2, 1, you kind of get lazier. And you're like, yeah, but I know it's 4, 3, 2, 1, right? So they took the coefficients. So see how that works? 1, -7, -10. Okay. Then they went, okay, here. See how I'm subtracting every time? How about I just anticipate the subtraction, and instead of putting plus 2 out here, x plus 2, I make it the opposite. So when I have x plus 2, I'm just going to put here, I'm going to solve. And I'm going to put -2 out here. That takes care of my subtraction. Because see how I subtract every time? Subtract, subtract. Got to remember to subtract. They just made it the opposite sign. So if it's x plus 2, they put the minus. Now, one more time. If this only works for linear, I'm dividing an x into an x squared. How many times will it go in? I always do x squared divided by x, so whatever the coefficient is, 1 time. So then they said, well, I'm just going to grab it, and it'll be 1 time. X goes into x, whatever the coefficient is, it'll be whatever that is, because it's x into x. I specifically said I want a single x with a variable with a coefficient of 1 in, so 1 goes into whatever that is, will be whatever that is. So if this was 2x squared, how many times would x go into 2x squared? 2. If this was 3x squared, how many times would x go into 3x squared? 3. Does that make sense? So whatever the coefficient is, that's how many times, because I'm specifically only doing it for x with a coefficient of 1. So it only works for certain ones. So they said, yeah, so then it's whatever it is. So there. Then we're going to do the same cycle. So we're going to multiply and subtract. So we're going to multiply, put it here, but instead of subtracting, I'm adding. So then I add them and I get -9. And then I multiply again, this times this, 18. I add them and I get 8. Compare. Right? 1 time, -9, That's my remainder. So you get it. This is the last number will always be my remainder. This, if I'm dividing x into x squared, because I have to tell you that in the question, I know that this is a single x, right? If I'm dividing x into x squared, I know this is x, and this is minus 9. So it's one less. I'm dividing a linear into this polynomial. It's one less degree. So if this was a power of 3, my first number would be squared, single, no number, just a number. Right? So it's always one less power. So I divide it in, and look, I get the same answer. X minus 9, remainder 8. So they take the coefficients. Okay, so one more time. They take the coefficients, and then they divide it by the opposite, so they get rid of the minus. They're still finding the same numbers, and this last number is going to be the remainder. Okay, let's try it again. I'm going to try it with this one. Okay, so watch one more time. Upside down, we write the coefficients. 1, -3, -10. Right, so 1, -3. What do I put on the outside? Not positive 2, but -2, because we're taking care of the minus. We drag down the first one because x divided by x would just be whatever, however many x's there were. It's always divided by itself. So here we multiply. This multiplies here. It'd be -2. Add it, I get -5. That's the -5. We multiply it again. We get 10. Here I got 0. That's my remainder. That's my remainder. My answer would be 1 less. If I'm dividing an x into an x squared, that's x minus 5. Because I know what the columns mean. It's 1 less. Okay? So synthetic takes away the variables and only keeps the coefficients. That make sense? It just saves you the time of writing all the variables, right? Because you know it'll always be 1 less and then head down. Okay, so let's try that again. Okay, so try it here on the next page. I gave you a ridiculously long one just to prove to you it'll work, even with a big long one. Kind of went too big on that one, but here we go. So it's going to be upside down to show it's synthetic. Right, so upside down to show it's synthetic. You don't have to use a ruler. I'm just using it to make it neater for you. Okay. On the outside, what do I want to put? If I'm dividing by, -3, opposite, because I'm taking care of the subtraction. Okay. Leave a space here below, because we're going to fill in numbers there. So leave a space here and write it a little bit above. We're going to write the coefficient. Oh, wait, are they in order? 5, 4, 3, 2, 1, none. Yes, right? So remember the columns have to match, otherwise the pattern doesn't work. So we're going to go 4, right? Leave some space, 1, -2, leave some space, 3, -5. You have to leave space in between because we're going to do our subtraction, and then there you go. So 4, coefficient 1, -2, 3, -5, 3. Leave the row space here because that's where our addition is going to happen, right? So remember, they're just compacting that long division. All right, here we go. So imagine, if I have x dividing into 4x to the 5, how many times will it go in? Right? So in your brain, you're going, oh, so instead of writing this out, x goes into 4x to the 5 4 times. So that's why we drag this one down, right? Because of this. Right? So first into the first, so we drag it down. So that's why I get 4. Does that make sense? It's always a linear. That's why it only works with the 1 coefficient. I'll show you what to do when there's a not a 1, but usually people are like, nah, that's too much work. I'll just do long division. And they're like, forget it. I can't remember another rule. So then, but you can use it. So people love it with this coefficient of 1 because it's just straightforward. If there's not a coefficient of 1, there's another pattern you have to follow. It gets a little bit more not so fun, okay? But we will ask you synthetic and polynomial, so the kind of easier synthetic. I will show you the one with the number in front, and we'll decide if we'll tell you if you have to know with the number in front or not, okay? Right, but definitely this type you'll have to know for sure, right, with the 1 in front, because it's the easiest type of synthetic. Okay, so grab that, we got that, 4, okay. Then what we do is, and you don't have to show this part, but we multiply, right, multiply, and you write it up here. So just like what we were doing in the long division, multiply and write it down. So I'm going to do that times that, so negative 12. Okay, negative 12. Add it, because you don't have to subtract anymore. So the nice thing is they took care of the subtraction. So add it, so negative 11. Do it again. The numbers start to get kind of big just because I made such a long polynomial. This times this, right, multiply. You get 33. Add it, you get 31. Same pattern, and you can do this for as long as you want now. This one times this one. This one times this one will be negative 93. Add it, negative 90. Now the numbers just get kind of crazy. So this one times this one, 270. Add it, I got 265. That times that, I got negative 795. Add it, I get negative 792. That's it. It's just the biggest polynomial we've ever tried. We shan't be graphing that. So we're just going to write a multiplication statement, and we'll stop there. That's all. It's just to show you can divide anything this way. So then my multiplication statement starts with a dividend. So it's going to be 4x to the 5 plus x to the 4 minus 2x cubed plus 3x squared minus 5x plus 3 equals, I can't write it horizontally. It's way too long, so I'll just go underneath. The divisor, which is x plus 3 times my quotient. So let's write my quotient. Which one's the remainder? The last number, right? So this one's always my remainder. The last number is my remainder. So this here. Now, what do I start with? If I know I'm dividing it by linear and it's power of 5, then this first one would be 4x to the power of 4. Does that make sense? One less. Then minus 11x to the power of 3 plus 31x to the power of 2 minus 90x to the power of 1, and then 265. Close it up, right? And then my remainder would be minus 792. You can just tack that on at the end, all done. And if you want to check it, expand it, collect like terms. Right? You can definitely double check to make sure that's right. All right. Let's try a shorter one. I just gave you the longest one possible. It's just like, I don't know, and I put a bunch down. Okay, so it's just to show you that it works for anything there. Let's try a shorter one. What am I asking you to remember to do on this one, though? How did I change it up? Yeah. Yes. Okay, you got to put that placeholder x to the power of 1 there. Okay, so we got it. I want you to fill it in. If it's missing something, you have to fill it in. It's like that column. It's the tens column, hundreds column, thousands column. You have to fill it in, otherwise it simply doesn't work. It doesn't match up. Okay, so you have to fill in the blank columns. So here we go. So we try this again. It's a shorter one. You don't have to use a ruler. I'm just doing it because my notes are getting messy here. So on the outside, I'm going to put 2. Right? Positive 2 to get rid of the minus. So that's done. On the inside, right? Remember, this here we've got x cubed minus x squared, 0x minus 4. Right? So this, I need you to remember. So that one here, we're missing that column. So right here. Okay, that column right there, 0x. Okay, Otherwise, right, the tens column, thousands column, we're trying to line those up. So then we're going to do over here 1, -1, 0, -4. Does that make sense? Okay, so you have to fill in the 0 there. That's what I'm trying to show you here. So just make sure you fill in this column. All right. So how many times will x go into x cubed? It's the same. It's always whatever the coefficient is. You drag it down, it's 1. Right, because you're dividing by a coefficient of 1. 2 times 1 is 2. Add it. So 1. 2 times 1, so 2. And yes, you can still add. 2 plus 0 is 2. We're okay. 2 times 2, 4. Add it, 0. Remember, my last column is always my remainder. That is always my remainder. Okay? So then my multiplication statement would be dividend equals divisor. Okay, quotient is this. How do I write the quotient? If I know I'm dividing a cubed by a single power, right, by a linear, then this first column would be x squared. Second column would be x. And third column, no x, and I have no remainder. Does that make sense? Anything else? Okay, I'm going to pause here.